Have you ever wondered why earthquakes occur, why mountains form, or why volcanoes erupt? Well, the answer lies beneath our feet, in the chaotic and ever-moving world of Earth's crust. You see, our planet's surface isn't a single solid piece. Rather, it's a puzzle of several large pieces known as tectonic plates. These plates are constantly on the move, shifting and sliding over, under, and past each other. This ceaseless movement is behind many of the Earth's most dramatic geological phenomena. From the tallest mountain ranges to the deepest ocean trenches, from the sudden jolt of an earthquake to the fiery eruption of a volcano, it all comes down to the movement of these tectonic plates. Where these plates meet, we find plate boundaries. These boundaries are the stages where the drama of Earth's geology plays out. Each boundary has its own unique characteristics and results in different geological phenomena. To understand these phenomena better, we delve into the three main types of plate boundaries and their unique characteristics. Imagine two giant pieces of the Earth's crust moving away from each other. This is what happens at divergent boundaries. Divergent boundaries are fascinating regions on our planet where tectonic plates don't collide or slide past each other, but instead they move apart. Now you might wonder, what happens to the space that's left in between? Well, it doesn't stay vacant for long as it becomes a hotbed for new crust creation. Think of it like a wound healing, where new skin grows to fill the gap. In the case of divergent boundaries, molten rock or magma rises from the mantle, filling the space and solidifying to form new crust. This process is constantly happening, albeit at a pace too slow for humans to see in real time. A well-known example of this is the Mid-Atlantic Ridge, which is essentially a mountain range beneath the ocean, formed by divergent boundaries. So, divergent boundaries are sites of constant creation, building new crust as the plates move apart. What happens when two of Earth's giant pieces meet head-on? Welcome to the world of convergent boundaries. Just imagine two colossal slabs of Earth's crust, each moving inexorably towards the other. They meet, they clash, they converge. This is precisely what happens at convergent boundaries. It's a fascinating spectacle of the natural world, where the forces unleashed are nothing short of astronomical. These areas of collision can result in the formation of mountains, like the majestic Himalayas, the highest peaks on our planet. Born out of the colossal clash between the Indian and Eurasian plates, these mountains are still growing today. But it's not just mountains that are formed. Deep-sea trenches, like the Mariana Trench, the deepest point in our oceans, are also a result of this titanic tussle. As one plate is forced under another in a process called subduction, it creates these immense underwater canyons. Volcanic activity, too, is a common feature at these boundaries, as the descending plate melts and rises to erupt on the surface. Convergent boundaries, therefore, are sites of immense geological activity and dramatic landscape creation. Now imagine two pieces of Earth's crust sliding past each other. This is the realm of transform boundaries. Transform boundaries are fascinating geological sites where tectonic plates don't collide head-on or pull apart, but instead they glide past each other horizontally. They're like dancers on a grand geological stage, constantly moving in a slick, side-by-side motion. This sliding, however, is not as smooth as it might sound. The immense friction between the plates often causes them to get stuck. But the plates are still trying to move, building up stress. Eventually, the stress becomes so great that the plates suddenly slip free. This release of energy causes the ground to shake, creating what we know as an earthquake. A famous example? The San Andreas Fault in California, a transform boundary that has been the epicenter of some significant earthquakes. In this constant dance of the Earth's crust, transform boundaries remind us of the dynamic nature of our planet.